Cool. All right. Since we're 10 minutes in and we don't want to lose any more audience, we'll probably kick off the two of us. So I'll start with we've got a nice session today to go with our public launch of our TypeScript code generator at Speakeasy. I'll share some more about that soon, but before we do, just wanted to say hi to everyone. Like I said, it's my first ever stream. I'm joined with Colin, the well-known Zod author, who I really admire for his work, and also recently working on Bun, which has also been amazing to watch. And yeah, I'm to kick off with introductions. I'm George. I'm one of the founding engineers at Speakeasy. I've been here for about 4 months, and my first major project has been to rebuild our TypeScript code generator. That's been quite exciting, but also quite daunting, and I'm really proud to see that come out live today. If you've been following the socials for Speakeasy, Colin's gonna Colin's work has played a big part in this SDK, or this generator rather, and we've really been working with him closely over the last few months. We're also proud sponsors of Zod, his very fine creation that's powering the generator. And he's going to be talking to me today about our work, and I'm going to be asking him about his work as well. I'm going to hand it off to you, Colin, for your introduction.
Sure. Yeah, I'm Colin. You did a great job. I should say Speakeasy is certainly a sponsor of Zod. They're the #1 sponsor of Zod. You guys are the the gold plus, the only gold plus sponsor, in that you guys went above and beyond the cutoff for gold. So now I'm thinking, as I'm evaluating Zod 4 and reworking some things, I'm gonna need to add a platinum or a some kind of super gold tier, so that you guys are appropriately rewarded for being the most generous sponsor of Zod. So I'm very happy to be here, and just absolutely love what Speakeasy is doing, and I'm kind of in awe as a DevRel of Speakeasy's kind of DevRel team and branding and docs design, and of course your incredible decision making to work closely with Zod in designing your new SDK. So I think you guys are, already doing great things, and it's really good to be here.
I should say it's going to be. Oh, sorry. Yeah, go on.
Oh, go for it. You're good.
I was going to say, hopefully it's going to become apparent how much we're using Zod and the degree to which it's powering all the features in this new generator. So yeah,
and we will get into it. I did just check the live stream, and I'm pretty sure my whole face is composed of about 4 pixels total. So just this will be higher res when we upload it after the fact, I think. But had some travel delays here. I'm coming back from the Sundance Film Festival in Utah, and currently stopping over in Boise, and I'm on Hyatt Wi-Fi, which I believe is 8 megabits down, some astonishing number like that. So hopefully the audio latency is all right from Boise to London, and it seems to be good so far. But yeah, if I just look like a smudge, just know that I'm actually a human with a high res face in real life.
Yep, that's fine. And yeah, for anyone that's curious, we are actually recording a high resolution version of this, and it should all come out quite nice later when we upload it. But yeah, maybe we should just dive into it and see how it goes.
Sounds good. Yeah. Did you want to kind of jump in with the TLDR on Speakeasy?
Yeah, that's probably a good jumping off point. So, like I said, I joined Speakeasy because I was very, very passionate about developer tooling, and I didn't think I was going to find a place that's trying to address this problem or at least a slice of this problem. But stars aligned, and I found Speakeasy. And what they're doing right now is building really amazing developer experiences for companies that want to ship SDKs on top of their APIs. The the level of like support is something like well, there's several languages that we ship for. Today's call is going to be about TypeScript, but if you jump on the website, you'll see that we generate for a number of targets, including Go, Python, Terraform, PHP, Ruby, Java. The whole gang is there. But yeah, the big draw with Speakeasy has been that like you give us an open API description, and we're going to give you the highest quality SDK without you having to invest much effort into like a development team to build that thing. And we're finding that we're saving a lot of companies a lot of resources from not having to like work on this problem themselves. And we're continuing to invest. Like we're kind of like a team of developers that's really polyglot and passionate about every language that we each deal with, and we're always tracking like where the industry is moving for each language and each ecosystem. And we're hoping that that's really coming through the developer experiences we're shipping to your customers or your users of your API. So yeah, that's kind of the blurb. And yeah, today's the special day for TypeScript, so I'm just going to be talking about that from here on.
Yes, though you guys do support a bunch of targets. Swift, C#, Go, Python, Ruby, more, I'm sure. But yeah, forget all those. It's all about TypeScript today. That's right. And Speakeasy broadly, I mean, seems to be kind of, the manifestation of just like, this is the kind of thing that OpenAPI was built for. And it's almost weird given that OpenAPI, it's been around for a bit. Am I right that Swagger became OpenAPI?
Yeah, that's exactly right.
And so
there's been a few manifestations of it. Nowadays, you'll hear people talk about primarily OpenAPI 3.0 and 3.1 is sort of like, there's not really a gentler name. But yeah, they're descendants of Swagger. And indeed, like they've been around for such a long time, and I don't think we've fully exploited what you can get, by asking developers describe your API for me in a document and like sort of handing that off to tooling. SDKs is like just one slice of this problem, but there's so much more that you can generate if you put the upfront effort into describing your APIs.
For sure. And I mean, it's a little ironic that the other project I have some association with is TRPC, which is kind of the anti-Speakeasy a little bit, where it's just like truly TypeScript is all we care about. If you are building your app in end-to-end TypeScript, then there's a way to kind of make it easy to have server-client communication, share code, things like that, and just be entirely in that ecosystem. But the kind of like dirty secret is, as soon as you need an iOS app or whatever, you're gonna have a hard time trying to do that in any kind of type-safe way, and you do need some kind of lingua franca like OpenAPI that you can use as the source of truth here. And I'm not gonna lie,
like TRPC, I had used TRPC before joining Speakeasy, and it was my introduction to Zod and other stuff in that ecosystem and the sort of design first mentality and whatnot. So I'd be lying if I didn't say it inspired a lot of what this TypeScript generator is. It's just that our input is an OpenAPI document, and your input in the TRPC world is literally your server sort of manifesting both the client and server interaction.
Yeah, and the current incarnation of TRPC I take precisely zero credit for. It literally, the current maintainer Alex has put out 10 major versions of TRPC since he took total control of the project. And I think specifically TRPC version 10, like it actually really seemed to have like pushed ahead kind of what a TypeScript like SDK can look like, and really like struck the right balances in terms of like you're validating the inputs, but maybe trying to rely on inference in the outputs of every procedure as much as possible, and kind of just like also factoring in kind of scalability of your API, because TypeScript, we all love it. But when you have like a big a huge API surface, and you're trying to keep everything statically typed, that ends up having to be represented internally in the compiler as a single insanely complicated type by the compiler. And TypeScript has its limits. It has its recursion depth, things like that. And so it kind of like definitely, I'm sure as you guys experimented with different code gen solutions, there's some that actually don't scale. gRPC, Alex was very careful about finding something that is kind of scales linearly, in the compiler and doesn't accidentally trip up there at all, as you're trying to represent these huge, complicated mushes of functions and methods and input types and things like that.
Yeah, definitely. We're sort of discovering some of these along the way, and fortunately, what we've built kind of scales quite a bit with it scales quite a bit with the size of OpenAPI documents that we've seen given to us. We can take some of the really ginormous ones, and sometimes the type checking can take a little longer, but it's not like an unreasonable amount of time. But it's been really good to work through this bit by bit and discover what we need to support.
And I'm sure you're seeing some monster API specs in your time from clients.
Yeah.
Are most of these, out of curiosity, usually just handwritten? That's kind of like in Git, it's the canonical representation of the API, or are there other tools that people use, maybe even GUI tools that have been common at all in your clients for kind of like generating the OpenAPI spec? I've always wondered.
Yeah, there's a few. There's at least sort of 3 modes that I associate to how people work with OpenAPI. There's this sort of the first category of folks that kind of write it off to the side, sometimes after the fact, that there's a server that already exists and they want to sort of describe it and transfer that description to developer tooling, or use it to update their documentation site. So that's the sort of most disconnected from between the specification and server. And sometimes that can drift. Sometimes one team's deploying the server code and the other team is documenting the OpenAPI specification. The second group are generating their OpenAPI from their server. So a good example of this are projects like FastAPI in the Python world, and Goa in the Go world, where you describe FastAPI is a more accurate one, where you kind of write your handlers. It kind of resembles, but not exactly, how you write the server side of TRPC, and it just there's an additional bit of utility where it can spit out an OpenAPI document from that from your implementation. And in their world, they're using decorators and stuff.
Decorators.
So you decorate your handlers and whatnot.
Decorators on plain functions. What a concept,
Yeah.
What an insane proposition. And types that are actually runtime introspectable. Yeah.
Right, exactly.
Sorry,
exactly.
It's one of my pet peeves is how long it has taken to get decorators on functions instead of classes in TypeScript. We got the proposal there to stage 3, 4, whatever it's at now, and at the end it's just future extensions could be decorators on functions. I don't know, we'll get there eventually, who cares? And I'm just that's all I want. That's all I want in life.
So that's a pretty decent chunk of the audience that we've seen, or the sort of target audience is they will have some framework, whether it's in Java, C# or Python, and they're writing the handlers and decorating them and spitting out the OpenAPI as a result. The third sort of group, which is what I've called the design first, it's a common term nowadays, design first approach to building your servers, where you design your public interface, and usually some tooling will kick in and generate stubs on your server, and also emit the OpenAPI document. But you have sort of a tight guarantee that the server will not run away from the design or the public interface, because it's derived from that. And then a popular project in this space, which I really love, is Goa, which is in the Go ecosystem. And so they have a little DSL language where you kind of describe your public interface and everything gets generated off the back of it, and then you kind of just implement your service to satisfy that. interface.
Okay.
And that's cool. Probably like that for me personally. That's my favorite way to build these APIs. But then comes the problem of like now you have a really nice pipeline for building handlers and backend functionality. We need something that carries that forward to how do we get a good developer experience on the client side from that, and then how do we use OpenAPI to deliver that. And yeah, that's kind of like the point of what we're building.
Okay. Did you want to? We didn't plan the details of how to do this, but were you gonna try to show any code, or were we just gonna try to get into?
Yeah, I guess like we for the people watching us, we didn't intend for this to be like a rigid format. We're going to be talking, Colin and I.
To say the least.
Sort of small outline. Yeah, there is a small outline that we're both looking at in Notion. But I think before I jump into the code, I wanted to sort of just discuss what came before and what comes now and what's coming soon. But yeah, so like I said, when I joined Speakeasy, we already had support for TypeScript. We were generating SDKs for that. There was quite a bit of room to improve those SDKs. They relied on a lot of stuff that made them clunky to support certain features in OpenAPI. So like one of the main features in OpenAPI was like unions. Like you can say an endpoint returns a cat or a dog, and that was kind of quite difficult for us to tackle in the previous generator. There was also other places where we just had to like say the type of something is any, and anyone that's a fierce TypeScript user just avoids any like hell, and if you can't avoid any, you use unknown, and if you can't avoid unknown, then yeah, you're kind of pulling your hair until you figure out how to swerve around that.
There is, I think, a bit of the there's a bit of like the Jedi meme here, where it's like, everyone uses any at the beginning, then you get up to the top of the bell curve, and you're just like, I never use any. I've mastered TypeScript, and then like at the Zen Jedi guy is kind of like, there's a time and a place for any, but just no one look at the Zod code base. I put in most of those any's at a time where I was at the beginner end of the bell curve, and now I've gotten all the way to the other end and have yet to replace a lot of them. But yeah, there's a lot of times you're writing a function, that the output type is going to be like, and this one really applies to library authors, but it's going to be some like insane conditional type that's going to be handwritten as the return type of this function. And then you do kind of like the runtime implementation of that logic, and you're just like, all right, I know these are both right. I've already typed up, the like return type up in the function declaration. And so when you get to the return line, you kind of might as well do as any. And the way TypeScript, does that, like the explicit return type up in the function just trumps the as any that you have just like at the return statement. So I think that's most of the any's in the Zod code base, and there are a lot of those, but theoretically I could just like move the return type down to the return statement, the return line, and do return blah 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 as complicated conditional type. But I've been too lazy, so yeah, that's where we're at with
that's fine. I think you sort of hit the nail on the head. Like any is a really useful tool when you know how to use it, and certainly like library authors like yourself are gonna have to use it until the type checker and the syntax catches up. Like unless there's some really interesting, every minor release of TypeScript brings a new capability that like removes a whole host of those any's and whatnot. But for us in our world, like in the SDK world, we don't want to like tackle, like we don't want to propagate any's. Like library authors that we're depending on, like tools like Zod are going to do a lot of the heavy lifting to give sort of a view of what the data is that's coming through the SDK. And that's why it was so important to pick something like Zod at the outset. We looked at other generators in the ecosystem as well, and we saw a whole sort of variety of how they tackled this problem. a lot of them kind of get the raw JSON from the server and they cast it, and we just pretend that everything's fine. Like we trust that the server is going to return something that matches our static type, which ends up being one of the worst mistakes you can do when building SDKs in TypeScript, because the time at which you define static types and the time that the server lives in are completely different, and there could be like all sorts of, let's call them temporal anomalies. Like, so the other sort of, this kind of carried into the design decisions for this new generator, is that the static typings have to be trustworthy. Like, you have to have something that carries over into the runtime and tells you, if something doesn't look like those types, we're going to fail loudly and explicitly. And that's where the real value of Zod is that you can have the TypeScript types backed by runtime validation, and we see this in practice. If the server or a vanilla JavaScript user is calling a method and they're passing the wrong stuff, and you don't have a type checker at that point in time, you only have the validation. It's just really key to have that there. Another design decision. Sorry?
Getting the errors to have this kind of rich, being able to know where in the data structure that was passed into this validator the problem occurred, be able to kind of have the path, through that big JSON to indicate like precisely where that is, because that will, in a lot of cases, be pretty important for displaying that error in, at the point where the user will want to be seeing it in the UI, things like that. Is
absolutely
vital and weirdly subtle, I guess. And that's like, honestly, error reporting is one of the things that I think might have been a bit of like a differentiating factor in Zod's popularity, just because there was a lot of inconsistency about how you want to do that, I think, in the tooling that existed back 3-4 years ago. So
absolutely,
a lot of people have been able to build on top of that bit.
It's been super important. I'll get into like some of the interesting findings we had when we shipped the generator to some of our existing customers. But I want to just cover off like one of the other goals, and it was also based on an observation about the developer tooling ecosystem around this problem. Like when I was surveying, and this also kind of applies to our previous generator, but when I was surveying it, we noticed a lot of SDKs, and you've probably come across this, where like, Acme Corp-Node SDK or Acme Corp-Browser SDK. And I didn't really like the proposition that, some of these tools and companies were putting forward, that you had to have two different experiences for client-side users and back-end users. I think like in 2024, there's been a lot of maturity around web standards, that you can now build like the same code that runs everywhere universally. That's kind of why you'll see in a lot of our marketing we call it universal TypeScript, because it's reflecting our goal that we want to ship one bit of code, one artifact that you publish to the world, that you document, you educate your users about, and it'll run anywhere that JavaScript runs. You don't have to maintain multiple incarnations of like JavaScript code that target different environments. So that was really important. Like, we don't put -browser or -node on our SDKs. Our previous SDKs used certain things that like would have normally locked it into a certain runtime. Like for example, we came from a world where we were using Axios. We've seen also open source generators build on top of Axios and other sort of tools in this space. Or use certain things that are unique to Node. Like, so streaming is going to be a key theme where folks will use the Node.js streams, the standard library streams, and you're immediately locked out of running your SDK on the web or running it on Bun or Dino unless those runtimes meet you halfway and like implement the Node.js interop, which they've been sort of feverishly trying to do. But we just wanted to like elide all of that and use the platform because it is quite ready to use everywhere.
And definitely,
and the other sort of aspect we saw was, Go
well, credit to the Node.js team for shipping fetch support In addition to all the other things they've done, making like the Node.js buffer built-in extend, uint array was huge. They didn't necessarily have to do that. I think they had to make some breaking changes to buffer from how it was originally implemented. And then, now they do support, I don't think as a global yet, but they've got readable stream, they've got writable stream. There is still that disconnect you're talking about with, streams.writable, streams.readable in standard library. And that's going to be a harder, gap to bridge. But I think things will, as is the story with JavaScript, things will shift over to the web standard now that it's supported just over, a period of years. It's fine that if these migrations take a while, I think, since, the new tooling that will be becoming popular imminently, like Speakeasy, SDK Generation, and things, will all know to use the web standard stuff and avoid all of this. But just to complain a little more about the idea of having separate NPM packages, suffixed with -node or -web, guys, subpath imports, they've been supported for a while, underutilized. I think you can now, with your exports field in package JSON, just have my package /node or my package /web or whatever, and I that's designed, I guess, for this kind of thing where you want to have one package that you can install but consume it from multiple environments. I think like the / thing, it just kind of is going to be intuitive for people. Very few libraries seem to have like really adopted this as their kind of like go-to kind of like choice for splitting up, environment-specific code in a single library. You see a lot of scoped packages more commonly, TRPC, for instance, you have to import, at TRPC/React or at TRPC/Node, or I think they even have at TRPC/Next, which is even at a different level of, importing stuff specific to a framework. I do see the appeal of splitting things up by an NPM organization logistically as well. But I do think subpath imports, if you're just going to have like a node thing and a web thing and you can't get away with web standards for some reason, or even, client server, whatever. Subpath imports are a nice, easy way to get there. Yeah.
Yeah, absolutely. I will caveat that there's a certain design decision which might seem a little controversial, but I hope I can convince folks about it, which was our choice to go into like the sort of CommonJS world and like ship CommonJS, because I will get into it, I promise you, but it's kind of what excluded us from using some of the more interesting ESM features like exports and imports.
I'll be there.
It's been an interesting journey.
CommonJS, I mean, it's very good, I gotta say. Like it's if you're kind of a fan of programming, even like it makes it feel like the language is just kind of like maximally dynamic in a way that is incredibly cool, like where like your import is itself a line of code, your require, as opposed to just being something that's kind of like structurally in like kind of a layer above the code itself. You can use dynamic imports and things, and but there's lots of caveats with that. Also in server settings. I mean,
maybe this is a good point to talk about it, because it was one of the most difficult design decisions that we had to make, and it was largely driven by the surveying our customers and our ecosystem more than it is what's conceptually right or wrong. Like we found that the majority, this is another interesting thing of like when we're working in a developer tooling space, is people come to you not because they're experts in Node.js and they selected you, or JavaScript and they selected you based on those rounds. They're coming to you because they're not experts in this space and they want your expertise to bridge a gap that they might have. And some of those folks don't just come in with zero expectations. Some of them come with certain expectations. So like the most immediate one we found was that like a lot of users are still using CommonJS in their code bases. It's not like transpiling from ESM to CommonJS with like TypeScript or any bundlers or anything. They're just using CommonJS in Node. That's still a big portion of users. The second sort of the second group of users are ones where they're like, why is this library forcing me to change my code base? Why is it forcing me to like go from CommonJS to ESM, or why isn't it importable from one to the other? Another group of users are like, why am I having to put the file extension on some of my imports and not others? And this is like an artifact of, it kind of reflects on in Node.js and other places. But like usually, if you're not using a bundler or something like that, you will encounter this, and we encountered it. Like some customers were like, your SDK back when we were prototyping is making me put a .js. And I've got just above it extensionless import. I'm like, please explain what's going on. And then kind of like you're also forced to, there's no more like index.js sugar anymore, right? So you just have to import index.js. So the total view of this was that what I found is that CommonJS is importable by ESM. That's good, check. We know that we can serve people that are using pure ESM code bases. CommonJS is also compatible with like the modern TypeScript module resolution strategies, so like Node 16 and Bundler. Check. And it also will work with a lot of people that are using Node Classic, Node Next, all those other module resolution strategies. If you don't use the exports declaration in package.json, Node.js still lets you use extensionless imports. So people will get the familiar, no need for an explicit extension. That was like a really late finding, is like, why is Node.js unhappy with me like dropping off the extensions? Oh, it's because even though it's a CommonJS SDK, the fact that it declares an exports block automatically means that Node.js will start asking you to put the extension. I'm like, when you combine the fact that like it has to run everywhere with maximum like reach to like, whatever the customers and their users are running, this turns out to be still the right choice. And I, please come to Twitter, come to wherever you can find me, and convince me otherwise. This sort of design decision came after a lot of exhaustion and research and iteration, and we landed on this approach.
I think it's the call. It's the right call at this stage of the switch.
Right.
And especially, like Node. I guess. Well, they're doing their best, but it's tricky when you have to, as a user, make both TypeScript and Node.js happy. There's times, especially before module resolution bundler happened, where there were certain scenarios where it was basically impossible. And module resolution bundler, really opened up a big field of tooling where it kind of like actually does reflect kind of the behavior that is mostly actually implemented by most bundlers in terms of like how forgiving they are in terms of if the extension is there or not. And so even though theoretically, that really did open a lot of doors. And it's tricky, I guess, as a consumer of Speakeasy, that you need to like change your module resolution to bundler, and you may be like, we're not a bundler, what is that? There's been confusion around that naming. It's hard to find a reason right now, if you're using a modern bundler or dev server like Vite or framework, to not switch over to bundler. It'll make yours and certainly the dev tool authors' lives a lot easier.
Yeah, certainly. And we've tested it like in those scenarios. We've tested the bundling our project in a bundling an SDK and a Next.js project, running it in Node, running it in Bun, running it even in Dino, which has its own sort of module loading mechanisms. And yeah, like so far it's been the right, like I feel like we've struck the right balance as far as which module flavor to use. And I'm glad that we can like have maximum compatibility.
And the client code though necessarily uses ESM, I would expect, right? Or is there a client generator that's designed to be called from the browser, or the SDK is fully expected to be called from Node?
No, the SDK is, you can npm install it into a Next.js project and start using it, and it'll be like either in like a, let's say, a React server component, which will be left for the server, but you can that same SDK, you can give it to React Query or SWR or whatever it is that you're using on the client side, and it will continue to work. And that's also the bundler doing the heavy lifting of bundling that code into like a vendor bundle or however it's doing its bundling. But we have tested that, and also like a tricky bit when you're targeting the front end ecosystem is making sure that tree shaking continues to work based on your like module format and how you've managed your exports and side effects and whatnot. So we also, I'll get to probably demo this a little later, that our SDK does tree shake away neatly, depending on whether you want to use a slice of it or the whole thing. But yeah, I think hopefully that's kind of like the whirlwind of like the design decisions we had to consider, like definitely that it runs everywhere, that it uses the platform, and that we minimize like third-party dependencies. Like I think the simplest SDK that we can build today has potentially one runtime dependency, which is Zod. Like it's always Zod. We had to pull in extra dependency for decimals or arbitrary precision decimals, because there's nothing like that in native JavaScript. But yeah, we've been able, from the previous generator to the new one. The previous one I think had like 5 or 6 dependencies, a lot of it to do with like decorators and reflection and whatnot, to now just sort of Zod doing the heavy lifting. And yeah, I've gone over like why this was such an important decision. Like Zod is, I can't state how important it has been as the underpinning for our SDKs. But yeah, it might be like a good point to sort of show you what we've done since we've last chatted, and show our audience what we've done. I have, sorry?
Let's do it. I'm ready to jump in.
Yeah. I have prepared I'm going to share my screen just in a second. Let's do that. Share screen, entire screen. So hopefully you can see my window now. For the folks playing at home, I have created Speakeasy SDKs. I think it's in here. Yep. So I have the things that I'm going to show off are in this public repository. I'll just throw that link into the YouTube chat just so that people can jump in. But yeah, this is, so before this webinar, I did prepare an example SDK using our new generator, and I've prepared an application that sort of imports that SDK. So let's just quickly go over what we're talking about. Like we've been saying, we take an OpenAPI document, or description as the proper name. That looks like this.
Do a slight zoom in.
Yeah, let's do that.
Oh,
hopefully that's better.
I'm looking at a smaller window than the YouTube viewers probably as well, so that's perfect. I can see it now.
Okay, that's cool. Yeah, so this is an OpenAPI document. I've got very disparate sort of endpoints in here. These are operations, and yeah, anatomically you have like a path for your operation, method, tags, which will decide where in your SDK this operation will be accessible from. So imagine sdk.pets.adopt is how you're going to call that operation when we code generate it. And then we have sort of the response format.
So the tags,
and you'll see these a lot. Sorry?
Tags is an array there, because you could kind of have maybe multiple aliases, like if you wanted that.
Precisely, yeah. So you can have comma something else, and that operation will be also available under that namespace in the TypeScript SDK. You can have a pets dot, like a literal dot something, and that will make it one level deeper. Like you'll have an additional nesting that way. So there's a few ways to do that. And if you already have been using tags like in your OpenAPI document for a different reason, because like this document goes into a whole bunch of places. Like if it goes into a documentation generator and that has expectations, we have our own sort of extension that lets you control the namespace in the SDK separate to this directive.
Nifty.
So there's a few options, but this is I'm just gonna what I want to sort of illustrate in this example is like as minimal as possible, like extensions, Speakeasy extensions. I want to show you how far you can take your Open API. But yeah, so that's kind of like an operation. There's a few here, like I'll just show them now and then we'll jump over the code. So we have like a pets.adopt, and that's going to return a pet. We're going to do file uploads as an example. So this one takes a file upload form and returns a result. So imagine like uploading to a bucket. This is going to be a really spicy one. This is the LLM chat. So we've been able to model, again, without any vendor lock-in or any fanciness, we've been able to model streaming responses. So like what you would expect a chat GPT or a similar product to return to you. Again, powered by Zod. I can't emphasize how much I love Zod. And then yeah, like another example which is going to showcase pagination. Like this is the banking.transact, and it's like create a transaction against an account. This is where we have to sort of, this one, list transactions. This is where we have to use some vendor syntax or vendor extension, because we want to give you like a nice pagination experience on top of that operation. And these are the schemas that like you've seen references to them up here. So for example, when you see that, that's referring to some reusable schema down below. And this is where Zod's going to do a lot of heavy lifting. Our generator is going to take these and convert them to Zod schemas. Like a lot of the work that I did was take JSON schema, which is what OpenAPI use, and create a Zod representation of that schema. So we can see like a pet here is a union of a dog or cat, and here's the dog or cat. So please stop me if I'm scrolling too fast, but like here's like the upload form for when we look at the file upload example. So that's going to take a file, which is a binary, and a path where you want it in the bucket, some hypothetical bucket. Mm-hmm. And then the upload result that comes from that. I will jump down to the chat, so that the LLM example, which was, I think, really sort of really proud of how we pulled that off. So a chat request is like you give the LLM a prompt, you're going to expect a response to that prompt, and you'll say that I want the response to be streamed. And you describe a stream, again, like OpenAPI, if you're familiar with their streaming API and other, OpenAI, not OpenAPI, and other products, they usually send you like different messages down the wire, and like we describe those as a union of different messages. So a stream can be sending you down a completion chunk or the termination message. They usually send like a literal done message to say like we're done sending you completions, and we're describing that as a union here. And that's the completion chunk. So if you dig deep enough, you'll see that the tokens that it wants you want to show on the screen will come through that. And that's the sentinel. The final message is a literal done. But we've been able to describe that without any vendor extensions. And then you'll see that carry over to the TypeScript example.
And so in that, this is beautiful. The union type declarations are very clean, as is just the YAML in general. I was imagining all of this as JSON. I'm not, but like this is just incredibly readable, which I'm sure it can be.
Yeah.
This adopt post endpoint. Am I right in thinking that there's no you don't need to like actually pass any parameters to it in the body, and it just returns?
Yeah, that's correct. This one is like
okay.
I just wanted to keep like the early example a bit more contrived and just show a simple like no input and just returns an output. But there are like examples where we do take a request body.
Great. Yep.
And
then
other
that
examples
can also have
where
its own schema. Very
exactly nice. Right. And so there's additional examples where you take a request body, but also path parameters, and then there's further examples which take query parameters as well. So you can see the distinction ID here between
for the transactions parameter. You've got the ID in curly braces in the path. And then further down, I see. You've defined that in parameters. Okay.
Yeah, exactly.
And then request body separately defined. Fantastic. Yep.
Yeah.
Also,
exactly.
the just looking at this, we'll talk about Zod 4, I think, in a little bit at the end, but it's given me an idea for how to have an API for basically, currently if in a Zod object, if you have any kind of optional schema, z.string.optional, and you just have that as a field in an object, Zod kind of needs to make a call whether or not you want to use the exact optional property types version of that, where does that mean that field can be the literal undefined, or can that field be omitted entirely from the object, that entire key?
Yeah.
And I'm thinking, that's kind of a tricky API problem, because I kind of made its current choices before exact optional property types existed, and I'm thinking I may need to add a dot required method on Zod object that would let you kind of strip away that that question mark and make a field, I guess, required, but still, you would have to set it to optional explicitly, I suppose. It's given me ideas. I like this.
Yeah, certainly. I can give you like a shorthand answer to that, and that like a lot of these, at least for the request side of things, are going to get serialized to either JSON or multi-part form data, and there's no real value in undefined in that world. Certainly in like the JSON side of things, that's going to be eliminated in the wire, like over the wire. And yeah, again, in sort of when you're dealing with form data, it's not going to go over the wire unless you have your server is specifically aware of the string undefined, which is like opening up a can of worm if you're going to interpret certain literal strings as special.
That's terrifying to me. Don't do that.
Yeah, exactly. But yeah, let's have a look at so let's pick one of these and jump over to our app. So this is a runnable example for people that want to clone this repository. I've made it so that I'm not publishing it to npm. Instead, we're aliasing the SDK package in our package.json. And it should be like a self-contained project that you can run. But here are some like example applications based on those API endpoints. The first one was the cat example, which you can see here. I'm going to switch over to my VS Code, and I hope people can see this, because what we want to do now is actually like, let's zoom in. So is that coming through for you, Colin?
Absolutely, that's perfect.
Cool. Yeah, so this is the same example that we had on GitHub. I want to just go over the fact that we are returning static types for everything. If I go to the definition of this, which was going to be the return type of that operation, it returns that reusable pet model. And if we go to pet, we can see that it's a dog or a cat. And we can keep drilling down, and you can see, for example, the definition of the dog. And all of this, these are the types, these types, the TypeScript types, comprise the public interface. Behind those types, we have the Zod schemas representing them. So if you scroll a little bit down when you're digging through this repository, you'll see that there's the pet, and there's this namespace called pet, which this was a convenient way for me to mark something as internal so it won't show up in your IntelliSense, because we're not quite ready to distribute the Zod schema as part of the public interface, but we are using it internally to do all the validation. But yeah, for every...
It takes that cue from JSDoc and won't autocomplete. That's actually really good to know. I didn't know that hack, and I've, I think if you have ever, just had a Zod schema and hit dot after it, you'll probably see a bunch of underscore prefix methods and things. It's good to know that I could do that. And there's also just a bunch of interfaces, which we'll probably talk about, that are exported from Zod kind of to support advanced use cases that probably should not be relied on. You guys found a great solution to this, which
you can. I mean, you're not stopped from actually literally typing it out in IntelliSense, doing the auto import, but it's not a promoted suggestion, which is kind of like a good compromise.
That's perfect. Yeah, I had no idea actually. That's fantastic to know.
But yeah, this is from at least in the case of pet, this is how we're describing it. It's saying it's a union. I've already talked to you about this before, why we don't use the inference tools that come with Zod, but for the sake of everyone watching this fresh, we wanted the TypeScript types to be like nice, statically defined. You can jump to definition and look at the literal type of a cat, for example. A lot of the folks, like I said, we're trying to appeal to folks that don't necessarily use TypeScript professionally or full-time or anything like that. So we don't want them to be introduced to all kinds of concepts from day one, and trying to understand how Zod works and what the types are coming out from a schema and whatnot. We want these to be like statically defined, high quality, part of the public interface, and we're tying them to Zod using like explicit declarations,
which is just
and
100% the right call. Yeah. I mean, having all those things just be interfaces or types, having it all work automatically with go to definition, you can just kind of skate through the types and not see a bunch of additional characters that are required to define the runtime construct. Not to mention the fact that you do, at least for Zod 3, slight foreshadowing for Zod 4, you need to do this explicit type annotation, z.zod type, if you want to define something that is recursive, either self-recursive or mutually recursive. And so it's that will be changing in Zod 4 in a way that I'm pretty excited about. But even in that scenario, I think there's always some uncertainty when you have recursive type structures in TypeScript, because TypeScript has you're really pushing the envelope in that case, and TypeScript has a way of doing very subtly breaking changes to how some of that works, that can be problematic even in minor versions of TypeScript, which is part of my job as a maintainer, is to try to make sure I find something that works with all major versions of TypeScript that are in use. But the absolute rock solid way to solve this problem is exactly this: have your types defined separately, and it's incredibly readable as well.
Absolutely, yeah. That mirrors my experience, and we've definitely. I'm very excited about what's cooking for Zod 4, but I won't spoil anything that you might be working on. But yeah, this is like the sort of the boilerplate example. I didn't really show it in the OpenAPI document because I didn't want it to get too long. But if you have descriptions and summaries and stuff, they're going to come through the JS doc when you hover as well. Like right now, there's nothing on this or this, but if you did. And please, invest in your documentation in the OpenAPI spec. You will get more value from your SDK, and your users will too. So that'll come through. But yeah, just to make sure that we're not selling snake oil, this does run. Let's just make sure we're in the right directory. So let's do npm run pets. So this is giving me a random. Also, I wanted to show you this, Colin, because I think I was quite thrilled with, part of. I've been using MSW for doing mocking, and in this case, I wanted to be a bit cheeky. I am using the internal types for things, so I grab the type of what I expect the server to send, which is sometimes different than what you get in the runtime. Like it could be snake cased or whatever, kebab cased or whatever, and I use that when I'm building mocks in MSW, and I know now that I have statically defined mocks or described mocks. I have the Zod schema, and I have the SDK fully typed. Like everything is end-to-end typed, at least in this sort of slice of the world. So my mocks are in fact typed correctly, and if they drift, so for example, if I do somehow mess with this, we're gonna have to cheat on TypeScript to get past this. But if for whatever reason they drift, then let's get a cat, please. Yep, there we go. So things have a panic and say invalid, received cats, expected dog, or whatever. Actually, no, this is going to iterate through each union member and give you the error. So yeah.
Right, yeah.
So it's quite nice once you have these utilities at your disposal. I think I am encouraged to expose schemas because you can go further if people have access to the schemas. but I just want to make sure that we know what the right way to have it as part of the public interface is.
Would you be able to pull out, so the schemas are in that namespace, but they're not exported, is that right?
They are in the namespace, but like if we try and, I'm going to try and sort of go back to what we were saying earlier, which is, I think, oh well, because I spoiled the surprise, like it's starting to like suggest these, but if I go back to this thing, why did I lose my IntelliSense now? Oh, here we go. Yeah, so let's drill down to a simple example that doesn't involve unions. So here's a dog. Notice how we describe, so this is what you're going to be dealing with as a user. This is what the SDK is going to give you to work with in the rest of your code. But in our world, we describe two things. We describe the inbound schema of that response. So this is what the server sends, and notice how we have things like favorite toys, like snake case, I believe is the terminology. And we say, like, we have a schema for a Zod schema that says this is what we expect the server to return. So it's going to give me the inbound representation, and through Zod, I'm going to validate it and transform it into a real dog that you're going to get. The reverse is also, we also model the reverse. So like the outbound schema is what a user is going to give the SDK, and the SDK is going to send to the server after transformation and validation. So the outbound is similar to the inbound in some instances. So this is going to take a SDK dog and create a server representation of the SDK dog, and then sort of send that through. And that's why we use transform here. Like we, oftentimes the casing is different between what the SDK produces and what the server expects. This was like a really fun thing about Speakeasy. Is like a lot of generators don't coalesce the casing based on the language you're working in. So if the server returns snake case, half your JavaScript's going to look like as snake case interleaved with camel case. But we just kind of went the extra mile, and we're doing the heavy lift to translate between different representations based on what's most idiomatic.
Yeah, that's a great call. And this, we discussed something during earlier discussions of the SDK about maybe an API, because I think most of the dot transforms here are going to be just renaming keys, translating from camel to snake. And we talked about maybe an API, some syntactic sugar, to make that little neater, little cleaner when you have a Zod object, which is something that I think is likely to make it into Zod 4 as well, and something I'm excited about. Or actually, that could make it into a minor, 3.23 pretty easily as well.
Yeah, that would be fantastic. Certainly, if it just reduces the verbosity. It might be like sugar for this sort of transform block, but if it reduces the verbosity and amount of code, yeah.
And you could do some like destructuring to make this a little, if you know that the keys are going to stay the same, like for the first 3 fields there, you could do. But that just adds more conditional logic into your code generator. And as a person who's written a lot of code generators myself, I appreciate kind of just like keeping everything kind of linear, Yeah, it's definitely it's in my back pocket that there's an optimization where we don't need the transform if everything lines up. But I definitely will sort of lean on that if we need to. You could also do, like you said, an option for performance, and you'll have to guarantee that this works as expected. But you could do direct mutations to the V object. Basically, v dot, like set favorite underscore toy to v dot toy, and then delete v dot, favorite toy camel case. This if you don't certainly want, like GC pressure. Yeah, exactly. This feels better as a fan of immutable operations, for sure. Oh yeah, for sure. I think these are all things that we're definitely sitting on these, waiting to see like when the right SDK is going to come along, or when the right user and customer combination is going to come along, and we're like, oh, I need this a bit more optimal. I was like, yep, we got you. We're gonna do these now. But it's sort of the pragmatic approach to it. Absolutely, it's all exactly what I would be doing for sure. Let's have a look. So one of the things I mentioned earlier is I wanted the SDK
to be human friendly. Like a lot of code generation ends up unreadable, and you're kind of told, don't worry about it. It's fine. You don't have to like deal with this. But in fact, when things go wrong, you do want to, you know, grab a debugger or instrument the code with some console.logs. Like I've many times gone into a node module, deep into my node modules, and patched some third-party package or added a debugger statement somewhere because I wanted to like pause there. We wanted to make sure that what we're generating is sort of comprehensible and you can step through it, and it's like low on abstractions. So like that adopt method that you saw earlier, it kind of has a very sort of linear orchestrated approach to building up to a request and then parsing the response. So like for instance, we have, you know, building up the headers for the request. We add a user agent that helps you like identify the request in your logs on the server. It's kind of like a nicely laid out user agent. If you had path parameters, this would be like elaborating the templated URL into a real, the templated path into a real path. And then the fetch call, which is literally under the hood calling fetch with a bit of construction. And then when we've got the response up here, we're gonna like match it against certain predicates as you've defined in your Open API. So if the response has a status code of 200 and it's JSON, then sort of grab the JSON and pass it to the Zod's inbound schema. So this is what we were mentioning earlier. We take the server representation and we parse it. We just there's like a bit of an envelope on the response side that we build, and that comes out with the pet result that you were seeing in the client side. We can see a more elaborate example of that if we look at the file upload example is a nice sort of, there's a bit more to it that we'll see here. Similar orchestration for headers. We don't have any custom headers in this operation, but we now have like a file upload form that we want to work through, and that's the outbound schema that's going to take the user's input, validate it, and make it ready to be put in form data. We go to lengths to support a different number of use cases. Like so, for file uploads, we know that in Dino there's not yet like form data that takes blobs, or sorry, it does take blobs, but it doesn't take files that are backed by the file system. If that makes any sense, you have to like read everything into memory and then upload it. But other runtimes have it. They're working on this, by the way. But for runtimes that have something that is blob-like, we kind of duck type here and go append it. So in Node.js, if you use open as blob on a 1 gig file, that's not going to get loaded into memory, and we're happy to take that. But like for other places where you can't get a file backed by the file system, you have to load it into memory. We also support putting that file like smack bang into the form data. But yeah, things sort of carry on like we saw before. So like it kind of, I'm hoping, and this is very subjective, that like it is downwards looking code as much as possible, imperative.
This code is gorgeous. I'm having a hard time imagining it being prettier if it was handcrafted. Yeah, I'm glad. But yeah, this is how things sort of progress. Like it's following the same sort of script. Things get more interesting when we look at more elaborate examples. So like I'm in the wrong folder. Sorry, I'm so zoomed in now. I'm losing my Sorry. I'll show you really quickly some more interesting things. Like for example, if I go to list transactions, that's going to return a list transaction response. I'm just going to jump through these to show you some interesting bits, and that's going to be an array of transactions from that response. So yeah, this is where we start to deal with complex types, and where Zod starts to really give us you saw the unions. Like solving unions alone was just such a massive win, but now we can like start to tackle custom types. So for example, enums, like for the currency, or if you want to use arbitrary precision decimals, we support those. So you can see like on the inbound, we say the currency is like, it has to be an enum of, if I was to follow this, you'll see it's a native enum of currencies. Well, yeah, that's the Zod schema, native enum. Love to see native enum in use.
Yeah. The amount, which like, servers usually dealing with money will either send you like amount in cents, or they'll send you the amount in as a string, because they don't want precision loss or anything when you unmarshal it or deserialize it. So we take that string and the inbound, and we transform it to a decimal for you to work with. And you've told us this in the OpenAPI spec, so we know how to build the Zod schema as a result.
So in your schema, we had that union up there of a decimal type or a number in the output type. But in your OpenAPI, in the OpenAPI spec, was it specified as a union as well?
Yeah, this was a this was a mishap that I'm amazing that you like sniped me on this, but I really appreciate it. No, that's totally fine. That's actually a hangover. Like it shouldn't. We shouldn't accept a number from the wire, but like we don't actually, like coming from the server, we don't accept a number. We accept a string. But when the user is giving us, let's say a user wants to create a transaction and we're reusing this model, we jump over to the outbound schema and we say that amount from the user can be a decimal or a number, or a JavaScript number. We're happy to take both. We're going to coalesce them either way to a string because that's what the server wants.
Yep. Fantastic.
So that's the asymmetry between what the server sends and what the user can send for a reusable type. There's an asymmetry in these areas.
And this is where the fact that Zod, I have gotten pushback, and I've often asked myself if it was wise to have each Zod type. A casual user may not know this, but every Zod type has both an input and an output inferred type associated with it. And for most things, for simple types, they never diverge. But as soon as you use like preprocess or transform, they do diverge, and it turns out to be it's pretty vital for fully representing the set of capabilities of a Zod schema, which can do mutations and pipeline these kinds of changes, especially with Zod pipeline, where you can actually just have two Zod schemas kind of like stapled together with some intermediate transform logic. And so it adds, it makes the IntelliSense view of a Zod schema look more complicated, but ultimately, like, it's just pragmatically required to kind of handle like these kinds of situations. Like, there's always kind of like a scenario where like you need to be converting between two types, and you want that transform to be encapsulated in the way in which you're defining your types. And so it's great to see some such like a idiomatic use case of it.
Yeah, in the early days I was trying to see if there was like a Zod primitive that allowed me to create this necessary asymmetry, and I think like whether it was you or others, I definitely saw multiple suggestions for APIs, I believe, in the wild, but like I believe it was pragmatic to kind of handle it yourself kind of thing, or otherwise it's just going to become more and more heavy to encompass in Zod. And that's sort of naturally led towards this sort of inbound and outbound concepts being described independently. But yeah, that's like for complex types, we're handling these. The transform API is really good. Sometimes we even like go through multiple stages with pipe, but it's very rare that we'll need to like pipe from one pipeline to another. Most of the stuff that's complex just gets one transform, and now you have the desired output. In this example, also worth showing the fact that the response type here is kind of special when you're paginating. It's actually an async iterable. In our previous SDK, you had to call. There wasn't any helper. You had to use a while loop with like some escape logic for when you're done, but you had to call .next and wait for a null value to escape. We've kind of that's still available because we want to be backwards compatible, but we give you an async iterable which has this beautiful, in my opinion, syntax, and under the hood we're just kind of like wrapping it up with symbol.async iterator and making it possible for you to iterate over the over the API. So under the hood, like once you've consumed a page, it's making another API request over and over to get more pages.
That's beautiful. And in this, for list transactions here, you have a, let's see, maybe I'm wrong about this, but was that the endpoint where there was also a URL parameter?
Yeah, correct. And that's, so this is going to take that as an argument. It's also going to take a cursor, but we don't need to pass the cursor for our initial call. You can if you want to start from the middle, or you have a persisted cursor somewhere. But
in this scenario,
if we go and look,
there's no required fields in the body as well. But if there were both a URL parameter and a request body, then where would you pass the body?
Yeah, so there would be a positional argument called request body, which will have the desired type.
Nice.
Maybe it's in this file, actually. Yeah, it is in this file. So like this is the create transaction operation. So it'll take the URL path parameter, and then it'll take a request body, which is a type we've defined to have currency and amount. And these get munged together into like one thing and then validated as a whole, because these are like the request input. So Zod's view is just, what is the input to an operation? I don't really care for HTTP semantics. I just want to give me the whole payload to validate, and then pick it apart however you want to use it.
Zod does not care about HTTP semantics, because I try not to care about HTTP semantics. And one of the benefits of TRPC is you don't need to worry about URL parameters versus query parameters versus body. It's all just it's all there, single object. But it is another pragmatism thing where you need REST. And in terms of type safety in a REST API, it's a very hard problem, because there's all these ways to provide inputs to a single REST endpoint. I mean, this approach is just really good. You take the URL parameters, put them in order as positional arguments, then your request body options. And then, it's just like you have the actual named fields as well. Like the positional parameters all have the names that were assigned to them back in your URL paths. So it's really good.
Yeah. So down here is like some of the examples I've shown so far. They didn't have URL parameters, so that used to be like an empty thing here. But now this function is going to take some additional bit. We also there's different encoding strategies. So this code popped in because the operation had path parameters, and we are doing encoding on it. Like I said, we could have used some crazy reflection or introspection JavaScript method that knew how to look through it, but actually our code is really literal. If you have multiple path parameters, query parameters with different encodings and whatnot, that's all laid out for you. There's no layer of abstraction for how to encode them. We want you to know that we're encoding it this way, and it's going to end up in the URL here. And likewise, you can see it's actually, so there's the path parameter with its encoding getting prepared to be put in the URL. Oops, sorry, jumped a bit. I lost my place. This transaction. Yep. So that's the path parameter. We're encoding simple. And then we're doing form encoding on the query, and then we're going to throw it all and build the URL from it. So there's no real magic for this to work.
And might be just ignorant of some encoding terminology here, but I'm scared to ask what explode true does. What's being exploded?
Explode true is to do with if you give me a query parameter value that's an object, how do I encode the object? Do you want me to stick the entire object literal with percent encoding into the query parameter, or do you want me to take every key from that object and promote that to a query parameter? So every key value becomes a query parameter, and that's defined as explode, true or false.
Nice. Okay. And if you have a more deeply nested object, do you do the kind of
this is why we can't use
concatenation?
Yeah, exactly right. This is why we can't use URL search params, because different servers have different strategies for encoding deep objects, simple values, various things. So we have to try and express encoding, which is a complex subject, as simply as possible, and we can't use just one way of doing it.
It's a fundamental. I mean, I've had many headaches trying to figure out how to represent. Usually what people ask for Zod is a way to validate fields inside of a form data in a way that is kind of has some internal structure, at least beyond like the very minimal, like, form data is literally just like a map of strings to strings. And people really want to be able to pull that out without a bunch of handwritten validation logic into a more rich object. And there's been very little I can do, I guess, in Zod for these same reasons. Just because it's like you just need to know kind of across the whole stack what was being done when that form data object was created, and it's a hard problem.
Yeah, exactly. I mean, I do like once you get in the groove of it, you realize like, yep, this isn't Zod's problem. I'd rather be dealing with it in user land. It actually is nicer to, like, I know it sounds counterintuitive, but it's kind of nice to have certain things in your world, because it ultimately means your code is more comprehensible. There's fewer abstractions to unpack. So it's, I sort of grew to appreciate my relationship with Zod as I was building this. I will show the final example. I think the most exciting one that I most recently built, I think last week we shipped it, which is service sent events. Again, it looks very familiar to pagination. You call an SDK method. The result field is going to be like optional in this case. So normally you would do like, I don't know, could not establish chat stream or something like that. You throw an error, but for now, to simplify the demo, I'm just kind of coalescing it. And then it's an async iterable, like a paginated API, and we're detecting the terminating message and printing like end of chat. But if we get an event from the server, we're going to print its content. So again, if I'm using Llama file, which is like, I'm not sure if folks are familiar with it. It's like you can run an LLM on your machine. So that's running in my terminal here. Like it's very dizzying output, but we're hitting that. It's hosting a server and we're hitting that. So that's just going to look like, I think it was npm run LLM. And we're getting streaming content from that LLM. And again, that was like, I'm going to go into it in the last few minutes we have, but like, it's going to stream slowly because right now I've got a live stream going and screen sharing and a whole bunch of other stuff, and I'm running this in a virtual machine. So bear with me, but I'm going to terminate this before it finishes and go back to show you the chat endpoint is, so everything's familiar up to this point. But if you look here, it's going to look like exactly the same as everything else that we've shown so far. But if I was to go into this inbound schema, we're going to see that this is going to take a readable stream. So the response body as is, we want the response body. We're going to create, we have an internal helper that, like, it's distributed with your library, that's going to take the stream with a decoder, and we're giving the decoder a Zod type. So like it's going to decode lines of text coming from the connection, and it's going to decide, is this JSON or is this raw text? If it's JSON, parse the JSON, then pass it on to the Zod schema. So we're like doing like, I was really sort of just, this is another level of appreciation for Zod. But you can see like we're taking lines from the connection that like lines of text, because that's what text event stream is that the server sends, and we're parsing these. So if I was to go to a completion chunk, we know that it's all coming down as text, but the text happens to have JSON in it. So we're doing like a bit of JSON.parse first, and I'm using context.addIssue if the server sent invalid JSON, and then I'm piping that to a validation. So we're like guaranteeing that the streaming content is going to be validated with rich types. There's no type assertions, there's no magic, and like, or we're not taking any shortcuts. So like when we say that this chat stream is going to return, let's go back to our example. When it's going to return, if I hover over data, so this is the event, like it's described as a union of either proper content like that we want to print or the termination message. And like over here we have the content to print, but over here I believe, oh well, if I had it, if we do event.data here, let's do void. I think I have 2/ installed on my machine. That's going to come out as, oh, not this one. Yeah. So like all of this is correctly parsed off the wire, gradually passed through Zod, and then given to you through this async iterator, and you're getting a very rich experience. This was shipped last week, and we were really excited about putting it in people's hands.
That's incredible. Yeah, really smart doing that. The union with the string literal. That's really good.
Mm-hmm. Yeah, and this is like a common thing we're seeing where like someone sends like maybe different JSON payloads interleaved with like just like a heartbeat message or a done message and whatnot, and you want to like try and express that without cheating, essentially.
Yeah. Yep. It's the best. It's the best version
like,
of this.
Yeah, exactly. Yeah, that's like sort of the whirlwind tour. I know it's kind of like been quite a bit, and I'm hoping. One, I wanted to like show you, as I'm a massive fan, about how I'm using your library, and I hope I didn't elicit any like shrieks or screams, or even internal ones. But I'm quite happy with how we've been able to compose over Zod and build some really cool features.
No internal shrieks, I assure you. Only internal amazement, and external amazement for that matter. It's really, really good, and it's just like. It's just the kind of thing where I'm just like, this should have been solved with this level of, I guess sophistication, but also just this level of like attention to the developer experience a long time ago, and it's bizarre that it wasn't. But I also think it's in some sense it's in the air a little bit because, kind of like sensibilities around TypeScript SDK APIs is kind of maybe like. Only kind of recently coalescing, I think, and like what that ideal developer experience looks like. And I think the impressive part is just how much this reflects that. Like it's you guys have a finger on the pulse here with API design, which I think is if there's anything that is has accounted for Zod's success, it's just like pretty being able to kind of understand exactly what it is that. Like the API that developers want and that experience and what to hide and what to show them. It's really just like looking at this, game recognized game. You guys really have the best, it's the best version of this that can exist. Yeah.
I really appreciate that. I think it's like a lot of things came together in like recent years to make a lot of this expressiveness possible, both in the web platform, like Zod coming into existence, and TypeScript sort of slowly but surely iterating on like new sort of constructs and type level features. Like it's all, and like our job is to keep an eye on all of it and make sure that we update our SDKs. A lot of the stuff we see in the wild kind of gets written once as a generator, like with a bunch of templates, and then just kind of forgotten or abandoned. And these are like living projects. So like something comes out in Zod, I'm going to go use it, and then sort of magically a bunch of GitHub actions in the world are going to run, and a bunch of people are going to get the benefits straight away because this central team is invested in the ecosystem. But yeah, this might be like a really good tangent, and I don't want to put you on the spot, but if you want to share anything about Zod 4, I'd love to hear about it. For anyone listening, I don't know anything about Zod 4. I've just been sort of interested.
Yeah, I think if I may say, I've done a great job of injecting some of the exciting features of Zod 4 over the course of this discussion. Certainly in terms of just like new functionality that kind of Zod 3 is structurally not capable of for just, really, honestly, TypeScript compiler reasons that are beyond me to explain. Zod 4 will have the ability to do, define recursive object types. The, slight spoiler, and other library authors feel free to steal this, I suppose, is that it relies on getters. for the fields of yours where the kind of recursion is introduced. And as it turns out, TypeScript is able to, you're able to just define a self-recursive object, for instance, in JavaScript or TypeScript for that matter, that actually has an inferred static type if you use getters. And so that I'm really excited about. We'd be able to do away with that kind of hard cast to z.zod type in those things. Possibly. If for people who are just trying to define recursive structures, or if there's something like drizzle ORM or something where you are defining TypeScript structures that reference each other and ideally have bidirectional references between your two database models, that can then be done now without any kind of casting. So that I think is going to be kind of a hallmark new feature. And then some of the DNA of Bun has also rubbed off on me in my time there, and so performance is going to be massively improved. There's some structural problems with how Zod currently represents parse results, where it's nice to have Zod itself. You can kind of represent things as discriminated unions, and it's like a pattern that TypeScript kind of encourages, and to have that discriminator key. But ultimately, that is how Zod represents the results of parse operations. But we can kind of make that a lot more performant if we don't have to allocate all those objects that just have like success true, success false, or something like that. To be clear, this is not going to change any of the external APIs of parse or parse sync or safe parse, but just internally inside of the method that's actually called underscore parse. If we kind of rewrite all those in a certain way, we can end up making certain operations, parsing a typical like object, for instance, a lot faster. I'm not going to say any numbers, but factor of 2 or 3 for like a simple object, sometimes more. And so I'm very excited about all of that. And maybe also that we'll see if this factors into what you guys might do as like a if you had like a Zod v4 target for your cogen. But there's currently no way to attach arbitrary metadata to a Zod schema, like a lone Zod schema, and that's been intentional because it's kind of ripe for abuse, and there's no way for me to kind of like for Zod to statically type what that metadata like should be out of the gate. Like it could kind of infer the type of whatever you pass into it, but then I think what I've realized is that the Zod just kind of needs some notion of like a collection of schemas. And then when you kind of initialize this collection, you can say like, okay, for every element in this collection, I want this, I want some metadata attached to it that fits this TypeScript type. And then, you can kind of imagine some of the ecosystem generation stuff that can be built on top of that, where you can say, I'm building a generator and I expect you to pass in a collection of schemas that have these set of fields defined in the metadata for each thing. So it does make it a little easier for Zod to be the kind of canonical source of truth for in more cases. Of course, in your guys' case, less relevant because it's all open API, as it should be, because it's cross language. But I think the notion of Zod collection does kind of open up more in terms of kind of TypeScript first cogen tooling. So that's coming down the pike, and just got to run that by some potential early adopters for feedback, like you guys have been doing for the last couple months here. And it's going to be great. It's going to be great.
Yeah, definitely. I mean, a lot of that sort of is quite exciting. I've come across some of these things that you're trying to address in Zod 3. I didn't get to demo it, but yeah, we encounter recursive types and we have to use z.lazy. But then again, you can solve every problem with indirection, so like that's always nice that we could have solved it now. But I'm sure it's going to be a lot nicer with v4, and same with unions and the metadata. The metadata, I kind of shared your pragmatism about it because I've seen it come up, and I think you've commented before. It's like it's not really for Zod 3 to pick up something like this, but I can certainly see like a second level of Zod frameworks getting spun off just by stuffing stuff into metadata, and then you kind of like stuck with an ecosystem dangling off it, and you can't change anything about it. So yeah, it can be a problem.
It is tough, metadata as like a generalizable mechanism for attaching data to a Zod, like schema that represents a type is valuable, but then it's always going to be hard. You can imagine like a use case. You're defining a validator for a form, a web form, and like you kind of want to be able to say, okay, first name : c.string, sure, but also like you need to be able to tell it what text to print to the screen. First space name, is what you want kind of above that field, for instance, in your UI, and then being able to indicate like the lowercase version of that even, or the plural version of first name if you like need to incorporate that into your error messages. And all of this, all the UI and the validation logic and error reporting and all this is, it's all tied in together in, complex ways. And I guess like it's going to be something I think about a lot is like, is there a way for Zod 4 with collections or metadata or this or that to compete with something that is like, if I design like the perfect library for designing like a form as like a data structure, like a data structure that you can define for a web form that contains, all of these like bits of information. Is there a way for Zod to kind of like approach the developer experience of that like use case specific library for defining forms? And that I think is what has been it's a very hard design challenge. I think we'll get close, and I'm excited to iterate on it in the next month or two.
We're definitely going to let you cook, and we're going to see what comes out of it, but it's going to be really exciting. I think we're at time. We started a little late and finished a little late, so I want to let you go and not take up too much of your time, but I really appreciate that you took this hour and a half with me, and I'm really appreciate that you let me show you what we've been able to do with Zod and with our new generator. It's been a hell of a time, so yeah.
It sure has, and I'm legit psyched to see your V2 SDK ship and see what people build with it, and this has been a fantastic conversation. Thanks, George.
Amazing. Thank you so much, Colin. Take care.
All right. Take care.